Hello dear students, and in today's class we are going to talk about the chemical reactions. What are all the types of chemical reactions? There are so many reactions taking place in our day-to-day life in and around us, and we are experiencing so many number of chemical reactions in the daily life. Among the chemical reactions, what are all the important types? The types of chemical reactions we are going to discuss in that. The first will be combination reactions. What are called combination reactions? These are the types. The element can combine with another element to form a compound, which means more than one reactant can combine with each other to form a single product. This is the category 1. One element is combining with other element to form a compound. For example, burning of coal, the carbon which is in the form of solid can combine with oxygen in the form of gas to form carbon dioxide gas. So it's a simple example of combination reaction. Combustion of coal. Burning of magnesium metal ribbon. Magnesium which is in the form of solid. This on burning with the help of air, we will be getting the magnesium oxide. It is in the form of solid. And we can have the balanced form of equation as follows. So the magnesium oxide combines with oxygen to form magnesium oxide. That is also an example of combination reaction. The combination reaction, the category 1, element combines with an element to form a compound, which means any kind of element we can take. The carbon, a non-metal, and the sulfur, a non-metal, which can combine with oxygen to form sulfur dioxide. Phosphorus that can combine with oxygen to form phosphorus pentoxide and trioxide. The metal like magnesium that combines with oxygen to form magnesium oxide. Likewise, the category 2, a compound can combine with another compound to form the third compound. One compound is in combination with one other compound to give a new compound. This is also a combination reaction. Just for an example, calcium oxide, CaO, the lime, when it is in contact with water, H2O, in the form of liquid, these two can combine with each other to form calcium hydroxide, which is in the form of aqueous. The calcium hydroxide solution, the slate lime we will be getting. And the equation is almost self-balanced equation. The lime, on dissolving in water, we will be the calcium hydroxide. Lime water is formed. So these are the examples of combination reaction. Category 1 in which element is combining with element. The category 2 in which compound is combining with compound. Is there any other chance? Yes, there are some more chances. We are going to discuss about them. Neutralization of an acid by a base and decomposition of food and certain vegetables. These are also comes under the category of exothermic reactions. So many number of examples are there. At least 1 or 2 examples we will discuss. Digestion of food. Our food substances are containing the carbohydrates, the energy giving substances. This is a carbohydrate. It is an example of carbohydrate. C6H12O6. The glucose what is stored in our body with the help of food during its digestion, while the burning of this in the form of gas, the oxygen, we can get the carbon dioxide, water, H2O. In addition to that, the energy is released out. So here the energy might be in the form of heat, and hence it's the best example of exothermic reaction. Whenever, wherever in a reaction, amount of energy is released out, heat energy is released, means it's an exothermic reaction. So while the digestion, this is what is happening in our body. Carbohydrate that is converted into carbon dioxide and then water. How to balance this chemical reaction? There are 6 carbon atoms, so better you write 6. And there are 12 hydrogen, so that I can multiply this also by 6. During the balancing of chemical reaction, there is a trick and there is a step in the reactant side or in the product side. If any free element is present, that should be balanced at last. Any free element, uncombined element. Here the oxygen is in free state. So don't try to balance oxygen initially. Oxygen should be balanced at last because it is in free state. So every element is now balanced except oxygen. Now you just count oxygen. 6 into 2, 12 plus 6. So totally there are 18 oxygen atoms. Here already there are 6 in the glucose. So 12 more are required. And in order to get 12 more oxygen, this can be multiplied by 6. Now you see there are 6 into 2, 12 plus 6, 18. In the opposite also we are finding the same 18 oxygen atom. So in this way the equation can be balanced. I repeat, any element in free state, that should be balanced finally. Before balancing that free state element, all other elements are to be properly balanced. Okay, so this is a simple example of exothermic reaction.